Hello everyone, welcome to the Rainbow Dash template tutorial. Here you will learn about the Rainbow Dash templates. This video will introduce how to implement the effect of the victory mechanism through the use of codes. Alright, let's get started. In the template, the effects of the victory mechanism include the finish line, spectator stand, and victory pop-up. We first build the finish line and the spectator stand in the scene. Place a cube part and a cylinder part in the scene. Adjust their position, size and color. Check their anchor properties. Modify their names, and be careful not to have repeated names. A texture is prepared here to use on the cube part. In the Game Resources view, select the cube part, and click the plus button next to the part name to add a decal. Drag the prepared texture into the decal and adjust the displayed face. Then change the fill type to tile and set the number of tiles. By doing so, we have built the victory mechanism. Click the Create button in the Assets view, and select New UI. Name the interface, you win, and click Confirm. Now, the layout file, and the Lua script with the same name appear in the Assets view. We double-click the layout file to enter the UI editing interface. Click on the white frame area to select the UI window. Change its anchor point to the center anchor point, then adjust the size to a suitable size. Drag a text box into the interface and resize it. Then also select the center anchor point and 0 the coordinates. Then modify its text, font size, font weight, text color, alignment, outline. Drag in another button. Change the name to Continue, and adjust it to an appropriate size. Check the lower anchor point, and also zero out the coordinates. Change the button text to Continue, and adjust the font size and text offset. We have roughly finished creating the victory pop-up UI. When we reach the finish line, we will be teleported to the spectator stand. To achieve such an effect, we need to use the collision detection. Click on Game Settings, select Trigger and Scripts, and click on Server Script Management. Create a new server script and change its name to Finish Line. Double-click the script to open the script editor. First, define a module, Finish Line. Then define two more variables. The line variable is used to store the finish line obtained from the scene. The win position variable is the teleport location after winning. Here we set it to the coordinates above the spectator stand in the scene. Define an externally accessible startup function, and pass a map parameter to it. Call the FindFirstChild function with the root property of the map parameter to get the finish line part in the scene. After obtaining the finish line part, use the functions provided by the editor to register the collision detection trigger. There are two such functions, which are the register handler function and the add handler function of the trigger class. The difference between the two is that the register handler function overwrites the existing triggers with the same trigger name, while the add handler function saves all the triggers with the same name in the trigger queue, and calls the triggers saved in the trigger queue in turn when activated. You can choose the appropriate function according to the content of your game. Here we choose the register handler function. The register handler function has 3 parameters. The first parameter is the configuration information of the object that activates the trigger. Here we get the player's configuration information through the entity.getConfig function. The second parameter is the trigger name. Here we use the trigger where the entity collides with the part. The third parameter is the callback function to be executed after the trigger is activated. The Object1 field of this parameter indicates the object that activated the trigger, in this case it is the player. The part field of this parameter indicates the part that collides with the player. Because there are many parts in the game scene, we have to determine whether the part colliding with the player and the finish line part are the same or not. If it's the same, then we set the player's location to the victory teleport location. We put this code into a local function. And then call that local function in the startup function. Save the code and open the server's main script. Use the require keyword to load the finish line module. Use the getStaticMap function of the world class to get the current map. In order to avoid the game object from not being fully loaded when the players enter the game, causing us not able to obtain the finish line part, we can start a timer and wait for 100 frames before calling the finish line module startup function. After completing the code, go back to the editor, run the game, and look at the results. As you can see, when the player arrives at the finish line, they are teleported to the spectator stand. After players reach the finish line, while teleporting, a victory pop-up appears. Clicking the button closes the pop-up interface. To achieve such an effect, we first need to implement communication between the server and the client. Click on Game Settings, select Trigger and Scripts, and click on Server Script Management. Open the finish line script. Here we use the Send to Client function under Package Handlers to send the protocol to the client. The Send to Client function requires 3 parameters. The first parameter is the player entity. Here we use the previously obtained variable, player. The second parameter is the protocol name, which can be set freely. Here we use when. The third parameter is the parameter the protocol carries, where we fill in an empty table or leave it out. Let's click on the Client Script Management, and open the client main script. Then use the Receive function under Package Handlers to receive the protocol from the server. There are 2 parameters here. The first parameter is the protocol name, which needs to be consistent with the protocol name of the sent function. The second parameter is a callback function that receives the protocol and executes it. More API-related content can be found in the official API documentation. Here we first define a variable, WhenUI, to store the created UI interface. Then define a local function. If WhenUI is empty, then use the function createGUI window under the UI class to create a UI window instance. We fill in the name of the UI file for the parameter here. Then set the parent node of WhenUI to UI.root. If WhenUI is not empty, the UI interface will be displayed. Then fill this function into the receive function as a callback function. This completes the logic for the victory pop-up. We also have to implement the logic to close the victory pop-up by clicking the button. Go back to the editor and open the script in the assets view of the victory pop-up interface. In the script of the same name that corresponds to the UI interface, we can use the self keyword to get the root node of the interface. Here, we use the self keyword to get the continue button object from the window class through the getChildByName function, and store it in the variable button. Use the getEvent function under the window class to get the button's click event. Define the variable event to represent the click event, and use the bind function to bind a callback function to the event. In the bound function, we set the UI interface to not display. After completing the code, go back to the editor, run the game, and look at the results. As you can see, the player's teleportation after victory, and the pop-up and closing effect of the victory message are all successfully implemented. This is all the content of this video. I hope this content can help you make better games. To learn more about the content related to the Rainbow Dash template, you can leave a comment below the video, or post it on the official forum. See you in the next video.